Um, so I guess a little bit about myself really quick. Uh, I'm a rising high school senior now. I'm homeschooled. I live in Northern Virginia. Uh, some of my favorite things are I like science and math a lot. I like teaching a lot. In my free time, I like reading, like going to the mall. I don't know. What is my favorite bread? Probably, I guess, wheat. Um, yeah, so I guess we'll just get into it. So first, we're going to talk about what sets are, and then we're going to talk about what set theory is used for, and then we're going to return to some terminology and notation and getting into the actual set theory itself. So a set is a collection of objects called elements. They are often numbers, but they can really be anything. It could be words or just things. The way you write a set is you use curly brackets, and then you put the elements in the set inside the brackets separated by commas. So if we had a set A, and we said that set A consists of all the odd numbers between 0 and 10, you would write A equals, and then curly brackets, 1, 3, 5, 7, 9, separated by commas. So that's what a set is. So it's kind of a simple concept at first, but it's a really powerful tool. So set theory is just studying these sets and what they can do. And it can do a lot of things, and it also underlies a lot of other fields of mathematics. So here, this donut shape is called a torus. It's a shape that comes up in a field of math called topology. And topology is, I guess, underlied, or set theory underlies a lot of topology. And then here, I don't know how many of you are familiar with functions, but functions also rely on set theory. We're not going to be getting into too many of these applications in this class, but this is what they can be used for down the line. So notation is the way that we write symbols to represent mathematical ideas. Set theory uses a lot of new symbols that you probably haven't seen before in other contexts in math. And so it can be a little overwhelming when you're seeing all these new symbols you've never seen before. But like as is the case oftentimes in math, once you understand the notations and the symbols and what they mean, the math becomes a lot easier. So just take it one symbol at a time, figure out the meaning behind it, and you'll be able to understand set theory. And I guess I should mention, feel free to ask me questions at any time if you don't understand. Does anyone have any questions so far? Cool. So this is the first symbol we're going to look at. This is the Greek letter epsilon, and it means is an element of. With the same set A that we had earlier with 1, 3, 5, 7, and 9, we could say that 1 is an element of A or 9 is an element of A. Or we could also say the same for 3, 5, or 7. If you put a line through the epsilon like this, it means is not an element of. So 4 is not an element of A. These next symbols are these two, which mean is a subset of. So they have almost the same meaning. We'll get into the difference between their meanings in a second. So a subset is just a set that is contained inside another set. So that means every element in the first set is also in the second set. So if we remember our set A before has 1, 3, 5, 7, and 9. Now let's introduce a set B, which has elements 1 and 3. You can say that B is a subset of A. And we can use this, either of these symbols in this case. The difference between these two subset symbols is that if it doesn't have a line, it only applies to proper subsets. And a proper subset is when the subset is not exactly the same as the original set. So if you have the line, a set is a subset of itself. And then if you don't have the line, a set is not a proper subset of itself. So that's a kind of a semantical difference. But if you have the line, a set is a subset of itself. If you don't have this line on the bottom, it means a set is not a subset of itself. Does anyone have any questions about subsets? Cool. So we have a few practice questions just to go over the notation we've learned so far. So we're going to do these one at a time. Can someone tell me how this first one would be read, how we would read this?
8 is an element of A.
Yeah, 8 is an element of A. And is that true or false?
It's very true.
Yep, it's true because 8 is an A. How about the second one? How would we read that?
11 is not a subset of A. Or 11 is not an element of A.
Yes, that's how you would read it. And is that true or false?
That's true.
Yep. All right, I want to get someone else to tell me how to read the next one.
C is a subset of B.
Okay. Let's get someone other than Aaron for the one after that. Is that true or false?
True.
Yeah, it's true because C consists of elements 1, 2, and 3, and all of those elements are in set A. How about the next one? I can see the chat. I see all of you guys putting your answers in. How would you read this one? Yep, you would read it as B is a subset of A. Is that true or false? Right, it's false because 11 is not in set A. How about the next one? How would we read that one? That starts with the set 1, 2, 3. Yeah, we would read it 1, 2, 3. The set 1, 2, 3 is a subset of C. Is that true or false?
False.
So this is going to be true. Or no, you're sorry. That's right. It is false. Because
It doesn't have a line.
we're only talking about proper subsets when we don't have the line. And when you're talking about proper subsets, it has to be, the two sets cannot be the same set. So 1, 2, 3 is not a proper subset of C. How about the last one?
Set 1, 2, 3 is a subset of C.
Yeah, and is that last one true or false? All right, this is going to be true because when we have the line, they're allowed to be the same set for it to be a subset. All right, any questions so far? If you have a question, just type it so I can answer it whenever I see. Okay, I'm going to move on. How do square roots work in sets? I'm not exactly sure what you're asking. See if you can come up with, okay. What about 4? Oh, so I don't want to get on too much of a tangent here, but yeah, if you take the square root of 4, we always say that it's just 2. And we don't usually apply operations to sets, so we wouldn't normally, you wouldn't take the square root of a set. You could say the set that consists of the square root of the elements in another set, but you wouldn't normally do that. All right. This next symbol means union. This is just a U, means union. We read this as A union B, or the union of A and B. And it means the union of two sets. It's a set of every element that is in each other set at least once. So if we have these two sets, A is 1, 3, 5, 7, 9, and then B is 1, 3, 8, and 10, their union would be 1, 3, 5, 7, 8, 9, 10. Note that you only include each element once, each distinct element once. So we don't include 2 1s, we only include 1 1. All right. This upside down U means intersection. So this is the intersection of B, A and B, or A intersection B. Intersection is the set of elements that are shared between two sets. So if we have these two sets that are the same as the ones from before, 1, 3, 5, 7, 9, and 1, 3, 8, 10, their intersection is the set 1 and 3, because 1 and 3 are the elements that are in each set. All right, now we're going to do some more practice. So here, imagine that each of these circles is a set. And so the blue circle is A, the green circle is B, and the red circle is C. So we're going to do it similarly before, where someone can tell me how to read
C intersection B.
And then you're going to tell me which colors in the picture, and some of them are kind of similar, but do your best. Tell me which colors in the picture make up that answer. Yeah, it's going to be C intersection B.
It's yellow.
It's yellow.
Is it just the yellow?
It's yellow and white.
It's also the pale pink.
So C intersection of C and B is just going to be this yellow and this white, because that's the overlap between sets C and B. How about the second one? How would you read that?
The intersection of A and B and C.
Yep, that's a fine way to say it. You could probably say, I think the way you would normally read that is just the intersection of A, B, and C. And which color or colors is that?
White. White.
Yep. How about the next one?
A union to C.
Yep. And what colors is that?
Blue, teal, white, pink, red, and yellow.
Yes, it's going to be everything except this green, because that's the only part that isn't anywhere in A or C. How about the next one?
A union B union C.
Union C, which is every single color.
Yep, it's every color, because that includes the all of every set. How about that last one?
The union of A and C intersection of B.
Yeah,
white, yellow,
you could say it that way. It's because you have the parentheses there, it's a little hard to read it in a way that isn't ambiguous. So this one, it's good that we have it written. So we know where the parentheses are. Let me make sure I know what the answer is. Yeah, it's going to be this light blue, white, and yellow. Right. Anyone have any questions about any of that? All right, we'll move on. So this is a little bit more information. So these are some common sets that you might see come up. So if you have this 0 with a slash through it, that means a set with no elements in it. This is called the empty set or the null set. If you see an n, that's the natural numbers, which consists of 1, 2, 3, 4, and so on. So all the integers from 1 and greater. The whole numbers are like the natural numbers, but they also include 0. And the whole numbers are represented by a W. The integers are represented by Z, and that's 1, 2, 3, and so on, 0, and then all the negative ones. And then Q is the rational numbers, and R is the real numbers. I didn't list them.
The integer Z.
What'd you say?
Why does the Z stand for integers?
Oh, I believe the German word for integers starts with a Z. I'm pretty sure that's why.
Thank you.
Yeah. So then Q is the rational numbers and R is the real numbers. So rational numbers are any number that can be expressed as a ratio between two numbers, or that can be written as a decimal or as a fraction. And then real numbers are basically every number that you're familiar with. So it also includes irrational numbers. And we're not going to be looking at these last two as much.
So real numbers, the way I think of them are basically everything except for the square root of negatives. Correct me if I'm wrong.
Yeah, real numbers is everything except for imaginary / complex numbers.
Yeah.
Yep, that's correct.
Is infinity a real number?
Yeah.
So
Concept,
Not
a
number. It's a concept. It's a concept.
Well,
Yeah,
most
we're
people
gonna talk
consider
about-
a number. Sure.
we're going to talk about infinity more in some of the later sessions. Set theory is a really useful tool for exploring infinity, because we cannot think about infinity as a number, but we can think about it as sets that have infinitely many elements. All right. So in this question, we've got a family. Parents Amanda and Bob, sons Chris and Dean, daughters Elizabeth and Fiona. Feel free to call them by their initials. So ask me if this is not well phrased, but if you think about this family as a set and certain sets within the family, come up with some statements using the family members as elements of sets to represent each of these terms. So think of a situation with these family members that could represent a subset. So if, let's say I had a set consisting of every family member, can someone tell me what a subset of the family might be? Yeah, you could say E and F, so you could say the daughters are a subset of the family, or the set of daughters is a subset of the family. How about union? So what are two sets that you could pick that you could take the union of them and get another set in the family? So some of you are saying things like A union B or E union F. So those are elements of sets. We can't take the union of elements, we can only take the union of sets. So an example you could have is you could take the set of parents and the set of children, and the union of the set of parents and the set of children would be the set of family members. Can someone give me an example of how to use is an element of with these family members?
Amanda is an element of the parents.
Yeah, that works. All right. So now we're going to talk about this thing called the principle of inclusion and exclusion. So the principle of inclusion and exclusion, which is abbreviated as PIE, is a tool to find the number of elements of a set, or the union of some number of sets. So if you want to find the union of two sets, or the size of the union of two sets, you can't just add the number of elements in the two sets, because then you'll overcount some things. So if I look at this set A and set B here, if I added the number of elements of set A to the number of elements of set B, I would include this light blue area twice. So we would count some elements twice. So the principle of inclusion exclusion is where you subtract whatever you overcount. So the union of two sets, here they wrote them as, or it's written as, we're trying to find the union of sets A1 and A2. We add the size of A1 and the size of A2, and then we subtract the intersection, because that's what we overcounted. If you want to find the size of the union of A1, A2, and A3, we start by adding the size of A1, the size of A2, and the size of A3. Then we subtract these overlaps. So we subtract the intersection of A1 and A2, the intersection of A2 and A3, and the intersection of A3 and A4. So that is, imagine you're adding A plus B plus C. Then we're subtracting these intersections, right? A3 is just another made up set. You can imagine them as A, B, and C if you want. So then after you subtract these sort of, I don't know, eye shapes, like ovally shapes, you've subtracted this middle part once too many times. So you have to add back the intersection between all three sets. So does that make any sense? Cool. This is a practice question. I've included the formulas in each of these slides, so you don't have to memorize them right now. So if we have a company and we have employees that can work the morning shift, the evening shift, or both. 18 employees work in mornings, 12 employees work in evenings, and 2 employees work both. How many employees are at the company using the principle of inclusion and exclusion? Yep, 12 is the size of our...
34.
So this is going to be 28, because 18 is the size of our first set, the set of employees who work mornings. 12 is the size of the second set, so you add 18 plus 12. And then the intersection between those two sets is the employees who can work both is 2. So you do 18 plus 12 minus 2. Any questions about that? All right. Yep, there, that's the solution. Okay. This is 1 with 3 sets. So we have a school where each student plays at least one sport from among football, soccer, and baseball. The football team has 50 people, the soccer team has 20 people, the baseball team has 30 people. Then 5 people play both soccer, or both football and soccer. 6 people play both football and baseball, and 2 people play both soccer and baseball. And 1 person plays all 3. So how many people are at the school? All right, I have the answer from 1 person. I want to see it from at least 1 more person, or at least a guess. All right. So we start by adding the size of each individual set. So that's 50 plus 20 plus 30. Then you subtract the intersection between each pair of sets. So that's 5 people who play football and soccer, 6 people who play football and baseball, and 2 people who play soccer and baseball. But now you have to add back the 1 that you subtracted an extra time. And this is the person who plays all 3 sports. And that gives 88. All right. I think I have one more thing. So this question might take a little while. If you have paper, it might be good to write it down. How would you use the principle of inclusion and exclusion to find the union of A, B, C, and D?
How do you draw a diagram with 4 circles?
Let's see. You sort of draw them in almost a cross shape. Try to remember how to. There we go. Can I make? Could do it like. All these are really not great circles. That was bad. Sort of like that. That's really bad, but something like that. Yes, I'm not an artist. PIE means principle of inclusion exclusion. All right. I hope people are working on it. Either way, does someone want to tell me what the first part of this would look like? So what would our first step be for this? Does anyone have an idea?
A union B union C union D is equal to A plus B plus C plus D minus A and then the upside down union thing. B minus B upside down union thing C minus C upside down union thing
You can say
A.
intersection for the
Okay.
upside down union.
Plus A intersection B intersection C intersection D.
I think that's close. I think there's a few extra terms you have
And
to
then you need to add
add and subtract.
A intersection B intersection from A intersection C.
And then you need to add a few more
And
things.
then the other three of those.
Yeah. And then what's the last term look like?
The middle A intersection B intersection C intersection D.
Yeah. Or so yeah, let's see. I'm gonna go, yeah, this is pretty long, but this is what the full answer looks like. So we have, and it's worth noting that we're not actually adding the sets themselves. We're adding the size of the sets, or the size of the sets. So we have the size of A plus size of B plus C plus D, and then we take the intersection of each pair of sets and subtract those. And then we take the intersection of each group of 3 sets, and we add those. And then finally, we subtract the intersection of all 4 sets. Anyone have any questions about that? Okay, so this is all I have for today. You guys were nice and fast, which is good. So if anyone wants to ask me any questions about this, you can do that. Can try and improvise something, or we can just end it now. Okay, doesn't seem like anyone has anything else. If you have any questions, you're free
Please
to ask
disable
them.
the chat. Oh, thanks.
Does anyone have any questions? Okay. Yeah, in that case, that's all I have. And you guys are free to go. I will post, you guys will have access to these slides tonight, and I will probably post a few questions too that you guys can do tomorrow. But the best thing you can do is make sure you're really familiar with the notation, because it's going to be helpful going forward. And that's all I have. I hope I see you guys next week.